Hi. So today I'm going to talk about the base n concept in mathematics and how to do that calculation in comparison in your Casio calculator. Well, base system is basically a number system by which a certain numbers, either one or two, like certain different numbers, which repeats itself after a cycle. So basically, it's like a wheel. In binary numbers, and there are only two numbers. So after those two numbers are completed, it again starts a new cycle with a new number starting from the left. You know, like in decimal 0, 1, 2, 3, 5, 6, 7, 9, 10. So after 9, it starts with 0, 1, 0. 1 starts on the left. So this is binary system. It has two numbers. The octal system has two numbers, 8 numbers, where 1, 2, 3, 4, 5, 6, 7, and then it again starts from 0. So there'll be a 1 before 0. So the next cycle will have a 10 in an octal system. In a decimal system, like I said, there are 10 different numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9 will be your total set of numbers, and then it'll start a new cycle with the number 1 before the number 0 in the next numbering system. Then there's the hexadecimal number system, where there are 16 different numbers ranging from 0 to 15, after which the numbering system restarts again with the number 1 before the old number. So if we look at the chart and how the numbers vary, this is the sequence by which the number goes. In the left, you have the decimal system. In the second one, binary, octal, hexadecimal. So as the decimal increases, the numbers, it starts to add up to the left. As its sequence ends, if you see in the binary and in the octal, you see in the octal from 16, 17. After 17, you go to 20. So that's its cycle. 0 to 7 was its cycle. In decimal, we all know 0 to 9 is its cycle. In hexadecimal, if you see, we've gotten to 1A, 1B, 1C. So 0 to 16 was 1, and after that, it'll start like 0. We only have numbers to 9. So after 9, it goes to, if we go to hexadecimal, see, we only have numbers in our culture till 9. So after 9, it goes to A, B, C, D, E, F. So that's the whole entire, its number system from 0 to F. So if we go to base 10, we have base 10 because we have 10 fingers. It's easier for us to count as a human being. So after 10 numbers, we restart in our hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Like that. So it comes in one, the bases are in ones, that is 10 to the power of 0, tens is 10 to the power of 1, hundreds is 10 to the power of 2. So that's how the numbers are sequenced, and the bundles of tens move to the right. Base 2 only has two numbers, 0 and 1. So this is the main numbering system that all electronic computing system use to calculate themselves. This is the binary system, and all calculations are done in the power of 2 or at the base of 2, and that's how we calculate. This is the hexadecimal system. So what we do here is there are 16 different numbers after which the cycle repeats itself. So the cycle is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. After which we start with 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1D, 1E, 1F. So if you want to calculate 30 in base E, it would be 2 to the power 4 would be 16. So 1 times 16 plus 2 to the power 3 would be 8. So 16 plus 8 would be 24. Plus 1 times 2 to the power 4 would be 2 to the power 2 would be 4. So 24 plus 4 is 28. And after that, 2 to the power 1 is 2. So 28 plus 2 would be 30. So that's your value of 30 in binary would be 1, 1, 1, 1, 0. In base 10, it's 3 into 10 to the power 1. That's 30. Plus 0 into 10 to the power 0. 10 to the power 0 would be 1, but since it's times 0, it's 0. So it's 30 is 30. So the same value in base 16 would be 1 times 16. That's 16. The remainder after 16 would be 14. So what is number 14 in our 1 to 16 cycle? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E. So E is number 14. 14 plus 16 would be number 30. As we know, anything to the power 0 is equal to 1, and that's how we do our calculation. So to give another representation of how this numbering system works, if we let the clock run out and see the numbers, then it goes like this. As you see, as octal number 7 ends, the octal cycle begins. As number 10 ends in the decimal, the number begins again. If you look at the hexadecimal, 16, 17, 18, 19, after 19, 1A, 1B, because that's how it goes. So number 31 is number 1F, is number 37 in octal, and number 1111 in binary. So for our purposes of using the Casio calculator, we need to do these conversions and these additions, subtraction, and multiplications from different numbering system. And as you can see, it can get a bit confusing using the decimal numbering system, hexadecimal, binary. So how do we do that in our Casio calculator? So first we got it set up, the calculator. So we do mode and type in number 4. So we've got decimal here. So when we go into this mode, this base N mode, these 4 keys over here come into effect. So we have decimal, hexadecimal, binary, and octal. So say we use the decimal and we got 5. We do equals to, so decimal 5, if you want to convert it into hexadecimal, it's going to be 5. It's going to, if we do the binary, then it's going to be 101. In octal, it should be 5. Now let's do decimal again. We know that 8 is going to be 1 in octal. So decimal 8 is going to be 8 in hexadecimal. It's going to be 1000 in binary, and it's going to be 10 in octal. So that's how you change or compare between the different values in your Casio calculator. Now we can also add and subtract all of this and do those primary functions that we have. So let's say we've got 10 decimal plus binary 1, 2, let's do 101 is equal to 1111 binary, which would be equal to in decimal as 15. So if we look 10 plus 101, so let's see what the number 5 in decimal is. 5 in decimal in binary is 101. So we've got the value in decimal we had as 10, right? Then we added 101, which is 5 in binary, for which we got 1111. See, which is the value of 15. 1111 is 15. So in that way, we can, by just getting that number and pressing equal to and then choosing between decimal, hexadecimal, binary, and octal, we can use that to do our calculations. Thank you.